All right, welcome to Unit 9, where we're going to start comparing two populations or groups. As you're going throughout the section, I just want you to keep in mind that this is not really going to be any different than what you did in Unit 8. The material is exactly the same. We're just going to change the formula up a little bit, and your conditions and assumptions will change because now we're comparing two groups instead of one. All right, so after this section, you'll be able to take a look at the shape, center, and spread of sampling distributions for two sample proportions. Okay, you're going to take a look at the conditions for doing inference about two proportions, and we'll talk about what that means in this section. We'll construct and interpret a confidence interval to compare two proportions, and then we will do a significance test to compare two proportions. All right, so hopefully you got that this section will be going over two proportions. Okay, all right, so let's just suppose that we want to compare the proportions of individuals with a certain characteristic in population 1 and population 2. Now, what I want you to notice about this is we are taking a look at two completely independent populations, population 1 and population 2. All right, so we're taking two completely different populations. We're going to call these parameters of interest P1 and P2. Now, what that means is our ideal strategy is to take separate random samples from each population. So I'm going to take a look at population 1, take a simple random sample. Take a look at population 2, take a simple random sample. It's like having two bins and taking a simple random sample from each bin. And then I'm going to compare the sample proportions with that characteristics. Okay? Same thing, what if we wanted to compare the effectiveness of treatment 1 and treatment 2 in a completely randomized experiment? So this is also the same thing as two populations. Treatment 1 and treatment 2 are two completely different treatments. Therefore, we're going to say that they're two populations. Okay. Now, this time the parameters, so remember parameters, your population proportion 1 and population proportion 2, we're going to compare the true proportions of successful outcomes for each treatment. So basically what that's saying is we have two groups. We have group 1 and group 2. What is the proportion of successes in group 1 and group 2? Okay, so here's a little table that's going to summarize the notation for the two situations. We have population of treatment 1. The parameter is P1, so that's your population proportion. The statistic that you actually get from the sample is P hat 1, because we're taking, this tells us what is the sample statistic, and then N1 is my sample size from my first population. Now take a look at the second population or treatment. We're going to take a look at what's the population proportion in that particular situation, and then the sample that you actually get is going to be P hat 2. Sorry, this is moving on its own. And the sample size is going to be N2. So what's your sample size for your second one? All right, we're going to compare the populations or treatments by doing inference about the difference between the two proportions. So basically, we're going to see if I have two different proportions, how far apart are they? Are the two proportions the same? Are they different? Is one bigger than the other? So we have two separate groups, and we're seeing if one is bigger, smaller, or the same as the other. Notice to perform inference, we're comparing the two parameters, not the sample. So same thing whenever we do our null and alternative hypothesis for single sample, we compare the populations. Okay, and then after we make a statement, okay, we think the populations are the same, we think they're different, we think one's bigger than the other, then we take a sample in order to verify that. Now, we're going to take, after we've determined, oh, I think the population proportion of 1 is bigger than the population proportion of 2, we're going to take a sample. That sample is the statistic that estimates the difference between the two sample proportions, P hat 1 and P hat 2. Now, in order to use P hat 1 and P hat 2, okay, we have to make sure that we understand what the sampling distribution looks like when I actually subtract the two proportions. Okay, so basically this means, once again, we're using two statistics to estimate the population parameter. We're checking to see, Okay, what is the difference between two populations? All right, so in order to take a look at this, let's explore the sampling distribution of the difference between two proportions. So let's start with two populations having a known proportion number of successes. So this one, we already know the population proportion. So at school 1, we know that 70% of the students did their homework last night. At school 2, 50% of their students did their homework last night. Okay, so we know the population proportion, okay, and we're going to actually compare them. All right, so let's suppose that the counselor at school 1 takes a simple random sample of 100 students and records the sample proportion that did their homework. That's actually going to be p hat 1. Okay, so the sample that they're going to take is p hat 1, all right? School 2's counselor takes a simple random sample of 200 students and records the sample proportion that did their homework. That's going to be p hat 2. So let's take a look at what does the difference in sample proportions look like? So if I actually subtract p hat 1 and p hat 2, I'm saying, hey, wait a second, how far apart are the difference in proportions of students that actually did their homework last night? All right, so what I did here is using the Fathom software, I generated a simple random sample of 100 students from school 1 and a simple random sample of students from school 2. So here's p hat 1. Right? So this is a whole bunch of 100 students, and we did the proportion of those 100 students that completed their homework. Here's p hat 2. Okay, so this was me taking 100 samples and finding out what proportion of students in that particular sample did their homework. Okay, we did this 1,000 times, so there's 1,000 examples in both of these. Now notice what C is. Okay, this one's pretty normal, this one's pretty normal. Take a look at C. This is the sampling distribution of the subtraction of them. So I just took school 1 minus school 2, and I got this sampling distribution over here. Well, what does that actually represent? That actually represents the difference in proportions, okay? So it's basically saying how much more did school 1 do than school 2 because I took school 1 minus school 2. So this 0.15 right here, that tells us that 15% more students did their homework in school 1 versus school 2, okay? So let's just take a look at the shape of these. The first one's approximately normal. The second one's approximately normal, so that means that since they're both approximately normal, okay, my sampling distribution of the subtraction is going to be normal. So if one's normal, second normal, third one's going to be normal when you combine them. What is the center? The center of this one was 70% did their homework. The center of my second school was 50% did their homework. Now, take a look at the center of the third one. So it's just 20%, okay? So I did p hat 1 minus p hat 2. That gives me 20% of the students did their homework, okay? Now, the spread's going to be a little bit tricky. We'll go over how we find that standard deviation. It comes from both. It comes from the standard deviation of both, but we'll go over that in a minute. Okay, so we sort of already talked about this. What do we notice about the shape, center, and spread? Okay, the shape, since they were both normal, it's going to be normal. The spread is actually, if you probably subtract the spreads on either end, that's going to be about your range is going to be the subtraction of the two. Okay, the center is the subtraction of both of them. And the spread, like I said, it's going to come from, now we're going to think about this for a second. So remember that here, if we have two random variables, how do we find the mean if we subtract them? Well, we actually just subtract the means. But remember way back, I forget what unit it is, but way back whenever you found the standard deviation of a subtraction of a random variable, you didn't just subtract the standard deviation, you actually found the addition of the variances and then took the square root to find the standard deviation. So that's where that formula is actually going to come from. Okay? All right, so we took a look at the shape, center, and spread of my sampling distributions. We said that they're both approximately normal, therefore the subtraction is going to be approximately normal. The center is 2.0 because we just took the difference between them. Okay, and then the spread is 0.058, but I said we'll talk about in a minute how we find that new standard deviation of p hat 1 minus p hat 2. All right, so both p hat 1 and p hat 2 are random variables. When we took a look at p hat 1 minus p hat 2, it's the difference between the two random variables. So we just found the distribution of subtracting the two because we're seeing how far apart, what is the difference between the two schools that did their homework. So way back in chapter 6, we learned, okay, this is what I was talking about on the previous slide, that for any two random variables, the mean, if you subtract them, is just the mean of the first minus the mean of the second. But the variance, or the standard deviation, when you subtract them, is the variance of the first plus the variance of the second, and then you take the square root to find the standard deviation. Okay, so that's going to come into play when we take a look at how we find our standard deviation of the sampling distributions. So let's say we choose a simple random sample of size n1 from population 1 and a simple random sample of n2 from population 2. So p1 and p2 are just your proportion of successes within that sample. Okay, now the shape, now take a look. Remember whenever we said how to check the normal condition, or is it approximately normal? In the past, we just did n times p1, and then we did n times 1 minus p1. Well, here we're just doing that twice. Well, why are we doing it twice? Because we have two different samples. So we're going to take n times p1 times n times 1 minus p1, and then we're going to do the same thing with the second one. So n2 times p2 and n2 times 1 minus p2, as long as those are both 10, the sampling distribution of p hat 1 minus p hat 2 is approximately normal. So you're just checking the normal distribution twice. The mean of the sampling distribution is just you subtracting the two population means. Now, take a look at the spread, okay? So the spread, this is your standard deviation. Notice how it's very similar to your formula from the previous unit with sampling distributions of proportions, the standard deviation. Notice how before we just did p1 times the 1 minus p1 divided by n1, and that because that was just for one. But now we have two proportions that we're looking at. So to find the new standard deviation, whenever we subtract the two sampling distributions, is to do the first one and then find the standard deviation of the second one, add them under the square root, then take the square root. And the reason for that is, remember, when you find the standard deviation of the subtraction of two random variables, you actually add the variances. So we're basically adding the variances here and then taking the square root. Okay. And then once again, we want to make sure we have the independence condition, or it's not more than, the population is 10 times the sample size. Okay, so this is just what it looks like if I take the two proportions and subtract them. The mean is you subtract the two means. Okay, the standard deviation is basically you have the standard deviation of the first one plus the second one, and then you take the square root of the whole thing. Okay. All right. So let's just take a look at an example. Let's suppose that there are two large high schools, each with more than 2,000 students in a certain town. School 1, 70% did their homework, and at school 2, 50% did their homework. So that's what they know. That's the population proportion. So the counselor at school 1 takes a simple random sample of 100 students, records the proportion that did their homework. School 2 takes a simple random sample of 200 students and records the proportion that did their homework. So we're going to describe the shape, the center, and spread of the sampling distribution of p hat 1 minus p hat 2. So when you do this, remember the shape is the normal distribution. The center is the mean of subtracting the two, and the spread is the same thing as your standard deviation. Well, how can I tell if it's normal? I just want to check the normal condition for both of them. So if I check the normal condition for my first sample, check the normal condition for my second sample, the same way that you did back in the other unit. Okay, since both of those are at least 10, if I subtract the two proportions, that sampling distribution is also going to be normal. Okay, the mean is just, since we're subtracting two random variables, 0.7 minus 0.5, so the mean of the subtraction of the sampling distributions will be 0.2. And then your standard deviation is that formula we talked about. Okay, 0.7 times 0.3, this is the first population proportion over 100. And then the second one is 0.5 times 0.5 divided by 200 because that's your second proportion of your distribution, and that gave us that 0.058 we were looking for.